All right, this lesson is going to be a three-part video series on naming and formula writing for polyatomic ionic compounds. So what we need to be able to do by the end of this three-part series is write a formula or write a name for any ionic substance that has something called a polyatomic ion. Now you might be wondering, what does that mean, polyatomic ion? Well, if we take this word and break it apart into pieces, poly is a prefix that stands for many, or in other words, more than one. And atomic just refers to atoms. So when we're referring to a polyatomic ion, we're talking about an ion that is made of many atoms. Whereas everything we've referred to thus far with being ions has been monoatomic, or in other words, ions that have been made of singular atoms. Now, the way that we're going to be able to do this successfully is through drawing. So we'll be drawing and color coding a lot today, polyatomic ions. Now, the reason why this is important is because many of the ionic compounds that we work with in everyday life, like when you look at your nutritional label on your water bottle, or you look at some of the salts and electrolytes in a Gatorade. Most of the electrolytes and ionic compounds that we're so used to working with are actually made with polyatomic ions. Now, that being said, polyatomic ions are a great way for us to get sources of things like potassium or calcium without having to consume those elements directly. So for example, people who have high blood pressure can consume more potassium in their diet to help lower their blood pressure. Now, potassium is very volatile and dangerous to work with by itself, so very rarely do you come across something that has pure potassium in it because it's too dangerous to consume. So almost all of our nutritional sources of potassium come from these polyatomic ions. So that being said, let's get started with talking about what the heck is a polyatomic ions. So when we talk about molecules, we're talking about these groups of atoms that are bonded together. We've seen lots of examples of molecules before. My favorite being water, or dihydrogen monoxide, is an example of a molecule. But we've got three examples pictured here of molecules. The first one is carbon and two oxygens, which is commonly known as carbon dioxide. The second one is nitrogen and two oxygens, which is nitrogen dioxide. And the last one is carbon and four hydrogens, which is carbon tetrahydride, or its common name, methane. This is what we use in our Bunsen burners, or butane. That being said, what all of these molecules have in common is they're neutral. In other words, there's no charge to any of these molecules. So they're not going to be attracted to positives or negatives particularly because they're neutral. Unless there's movement of electrons within the molecules, which does happen sometimes, like we saw, a neutral wall can be attracted to a charged balloon. These objects that are neutral, these molecules that are neutral, are not going to interact with each other. However, there are some molecules that have charge. Molecules that have charge are no longer called molecules, they're called ions. And since they're ions that are made of more than one atom, they're polyatomic ions. So a great example of this is the molecule NH4. That's one nitrogen combined with four hydrogens. That group of atoms overall is not neutral. Overall, that group of atoms has a positive one charge. So if I had another group of NH4, it would also be positive. And what would happen when these two molecules come in contact is they would repel. Why? Because they're both positively charged. So polyatomic ions behave differently with one another than monoatomic ions do. I guess I misspoke. They behave differently with each other than regular molecules behave with one another. So let's look at some more examples on your list of ions, of polyatomic ions. So you should have this list on the back of your periodic table. It should be the newest one that you got this unit. These are lists of common ions. Now, what we've mostly been working with is the monoatomic ions. So most of the left side is monoatomic, with one exception here. There's one polyatomic ion on the left-hand side, but everything else is monoatomic because it's only made of one atom. We've got our one example of a polyatomic ion, and that is the NH4 molecule we were actually just looking at. This NH4 molecule has a +1 charge, and its true name is ammonium. Now, if I look on the right side, our focus has been a little bit more limited. The monoatomic ion section is much smaller on the right side of our list. There are, however, many polyatomic ions. So rather than highlight all of them, I'll just highlight this section. Oops, that was a little bumpy. There we go. So what we need to be able to do is read these formulas and translate them into drawings. This is how we're going to write our formulas and make our names, is by being able to take these ions and draw them, similar to what we've seen right here. So we're going to do a couple of examples, and there isn't going to necessarily be room or a ton of room on your paper. So I'd advise that you maybe write in the margin or on a separate sheet of paper or on a whiteboard so you get a couple of examples. So what we'll need to be able to do is take polyatomic ions, either from their formula or their name, and draw them. So let's do a couple of examples to start with. If you've got multiple colors, this would be a great opportunity to use them. So let's focus on our first polyatomic ion, CO3 with a -2 charge. What I'm going to do is I'm going to color code my different elements in my drawing. So carbon, I'll use red for, and oxygen, I'll use blue for. So according to my formula, this molecule contains one carbon atom. However, it contains 3 oxygen atoms. So I'm going to draw 3 oxygen atoms connected or bonded to this carbon via these lines. Now, the last thing that I'm going to do is I'm going to address the charge. Now, this molecule overall is not neutral. Overall, this molecule has a -2 charge. So I'm going to show that this whole group of atoms has a -2 charge. And I can do that by kind of outlining the whole molecule with a -2. So when we're illustrating polyatomic ions, it's important that we're illustrating the formula correctly and that we're illustrating the charge of the molecule overall. So let's look for chromate on our list of ions next. Chromate is not the one positive polyatomic ion, which means it must be in this list on the right. So as I go down my list, oh, there's chromate. So chromate's formula is CrO4 with a -2 charge. So I'm going to copy that over here. Cr, capital lowercase, indicates actually that this is one element. And then O4 is a different element, oxygen, and there are 4 of them. And the charge for this molecule overall is -2. So let's get started with illustrating this. So Cr is actually my abbreviation for chromium. So according to this formula, there is 1 chromium atom in this molecule. There are 4 oxygen atoms in this molecule. So I'm going to draw 4 oxygens connected. And then overall, this molecule has a -2 charge. So let's illustrate that. Perfect. So if you'd like, go ahead and try the last one, ammonium. You can pause the video and unpause to see if you're doing this correctly and get some feedback. All right, I'm assuming if you're listening to this, that means you've already attempted to draw ammonium without my help. So let's get started with checking your answer. So when you looked for ammonium on your list, hopefully you found that it was the one positive polyatomic ion. That would have made your search very short. Ammonium's formula is NH4 with a positive 1 charge. So there's 1 nitrogen and 4 hydrogens in the molecule, and it has a +1 charge overall. So when I draw this molecule, I'm going to draw 1 atom of nitrogen connected to 4 atoms of hydrogen. Wonderful. And overall, this molecule has got a +1 charge. So now that we've got some practice drawing polyatomic ions and associating their names and formulas together with our list, go ahead and get some independent practice on the polyatomic ions worksheet 1.